Good morning, grade 10s. Today we're going to start with a very new section. It's called mechanics. And it's very important that you need to know and understand what we're going to do in this lesson. We are going to start with vectors and scalars, and you're going to use the vectors and scalars when you get to Newton's laws and free body diagram. So it's important that you understand how the vectors work, what they mean, and the mechanics section is also divided into other topics called motion in one dimension. What you need to know at this point and energy, physical amounts. Okay, you need to be able to name a few physical amounts. For example, we get mass, we get time, we get weight, we have force, we have charge. Since you've finished electric circuits, you should know what charge is. Okay, these physical amounts are classified into two groups. Okay, you get vectors and you get scalars. It's important that you know the difference between the two. So what is a vector? A vector is a quantity with a magnitude as well as a direction. Okay, what is a scalar? A scalar is a quantity that only has a magnitude. Okay, so it's important that you need to know the important difference between a scalar and a vector. A scalar only has a magnitude, that is a numerical amount. A vector has magnitude and a direction. Okay, so can you give me examples? Give me examples of a vector. Anyone? So, yes, an example of a vector is a force. So, force is measured in newtons. And since it's a vector, it's got a direction. So, for example, if you accidentally push your friend, you exert a certain amount of force, but you also push your friend in a specific direction. That is what makes force a vector. So, what is an example of a scalar? Can anyone tell me? Okay, yes. So time. Time is a scalar because if someone asks you, what's the time? Then you look at your watch and you tell them, okay, it is 5:30. And you don't tell them it's 5:30 west or it's 5:30 down. No, you just tell them it's 5:30 because time is a scalar. It doesn't have direction. We move on to vector examples. And as we've just mentioned, we have force, and that's denoted by the symbol capital F. We have weight, that's denoted by the symbol capital F and with a subscript G. We have displacement, that's with the symbol delta X. Displacement means when you travel a distance, you have a starting point and you have an ending point. And delta X means you have X final minus X initial. Then you have velocity. Velocity is denoted by lowercase v. Okay, the examples of scalars. Time, as we've just mentioned, is denoted by delta t or just t. We have mass, denoted by m. We have charge, denoted by q. We have frequency, denoted by lowercase f. We have energy, denoted by capital W. We have resistance, denoted by capital R. We have electric current, denoted by capital I. And temperature, denoted by capital T. How do we do additions and subtractions with vectors? Is it the same? So, scalars, as we've mentioned, they only have magnitude, which means they're just numerical values. And that means they can be added or subtracted like normal numbers are added and subtracted. But when we get to vectors, we have to consider the direction. So we cannot add and subtract vectors like normal numbers. We know that the result of a vector addition and subtraction is influenced by the direction of the vector. So, common misconceptions is the difference between mass and weight. We can't say mass and weight is the same. Mass and weight are completely different because mass is a scalar and weight is a vector. And when we look at mass, we see that mass is a measure of the amount of matter that an object consists of. And mass is measured in kilograms. When we look at weight, we see that weight is the gravitational force. Remember, force is also a vector. It's a gravitational force that the Earth exerts on any object on or near its surface, which means we have a direction, and the unit for force is newtons, and it's in a specific direction.